So this is what I guess this is. I don't know. Lecture what 46? I don't know. But this is going to be our official last class on Cinco de Mayo. Now, I would be happy to schedule any Zoom meetings with any of you who need it over the next week or so, but we're not going to have any more quote unquote last class or more class. So just a couple housekeeping things that you should keep in mind. First and foremost, as I just said, this is our last class. The final is going to be posted. I don't want to use live. That might confuse some of you. The final will be available tomorrow on Canvas. And so it is due next Wednesday. So you'll have at least a week. If I get it done earlier, I'll post it tonight. So it's going to be due next Wednesday, which is 7 days from now, right? So that's 5/12. Or yeah, no, 5/13. Because today's the 5th. By midnight. So the reason it's going to be midnight is because I have to grade them all, and I have to have your grades due by Friday. A couple other things that are very important that you understand. I've received a few emails from students about this whole pass-fail business that the university is offering. Let me be very clear. You don't need to choose that until after you receive your grade. So next Friday, I will submit your grades. Then, once your grades are official in the university system, you see what grade you have, A, B, C, D, E, F, whatever. And then at that point, you decide whether you want a pass or a fail. Does that make sense? If it doesn't, please ask or reach out to your advisor. Again, let me reiterate this. You do not have to choose whether you want the pass-fail option until after your grades are submitted. Is that clear? So
if you're satisfied with your grade, you can just leave it that way, right?
Yeah, if you're fine, you don't do anything. If you get an A, why the hell would you want to change it? Now, some of you might get a B or C and say, well, I don't want to change that. I'm going to leave it, right? So you have that option.
So instead of, we could just change it to pass-fail?
That's right, yeah.
So with the pass-fail, like how exactly would that impact GPA-wise?
Exactly. It doesn't help, it doesn't hurt.
Okay.
Yeah, so, I mean, look, it's going to, every one of you, the university, I believe, has something. I mean, you can always retroactively change it later. But for example, you know, if you're in engineering, you don't want the pass-fail option because the school won't accept the credits. Pitt won't. So if you're in a certain program, you know, the pass-fail is not going to be an option for you. You need to accept your grade, whatever it is. That's, you know, in certain other programs, you know, they won't accept the credit unless there's a letter grade to it. If you're curious about any of that, just reach out to me. I'll give you the information that I'm aware of, or I'll pass you along to whoever could answer the question for you.
Did you get the email sent you or no?
Yeah, I did. Thank you. I have that submitted. We might not just get an answer yet because it's finals week, and
okay.
Yeah, do you understand what I'm saying? So yeah, we'll hopefully, we'll figure that out within the next week or so. That way you don't end up doing anything. You should be fine right now though. I mean, you're referring to the email about like the classes and stuff, right?
Yeah.
Yeah. Okay. So, any other questions about the grades? I do know some of you email me about your grade. I am trying to keep up with that. It's just, again, it's not as easy to keep up with that as you'd like, considering everything that's happening right now. But rest assured, if you are missing an assignment or anything, I will, before I give you a 0 on it, I'll make sure you know that you're missing something. So a lot of you, it'll show that you don't have a grade for something just because I didn't grade it yet. So it's not that you didn't submit it, it's just that I haven't put the official grade in. So I hope that, you understand that in Canvas. Okay, any other questions about grades? Comments, concerns? Okay, so again, the final will go live no later than tomorrow morning. Hopefully tonight it'll be up there if you want to get a jump start on it. You have a week or so to do it. I don't suspect you'll need a week. However, if you want to take a week, you can. I don't plan on having class Thursday, but as long as my schedule has some holes in it, which it should, I just don't know what time, I'd be happy to have any practice sessions. If you guys want to, ask questions on Zoom, I'd be happy to do that. It's just, I want to make sure you guys have free time to do your other courses and, all that fun stuff. So I don't want to hold a class and make it seem like you feel obligated to join the party. Okay. Okay. So I don't see any questions on the chat or anything right now about the course. So let's do some examples. And as I said, feel free to interject at any time if you are curious about how to do some of these problems. So let's change the color and let's go to, you said number 2 and, oh, someone's typing now. I like this. Better late than never. Let's see what the chat says. Oh, Joel, is there another homework? There will not be another homework. So the last one will be 13. Now that said, that we're going to talk about one more thing today briefly that it is fair game for the final, but there won't be any homework on it.
So we doing review today?
Mostly, yeah.
Okay.
I do want to talk about one thing. It's not necessarily review, but it's very similar to what we've been doing. So it's not like it doesn't require, a 50-minute lecture. So sort of that, you'll see what I mean in a second. Carly, the last day from my math lab is also next Wednesday. Again, I'm giving you as long as I can, but I have to grade these things. So basically next week I'll be spending a lot of time grading all day, Thursday and Friday. So if you would really need a little bit of an extension on the My Math Lab past Wednesday, just shoot me an email. I can open it back up. But I'd prefer everything to be in before that. All right. I think that's it. All right, cool. So, all right, let's do some of these. Where'd my pen go? Let's do some problems. So on homework 13, well, let's just go to a new page so it's not so confusing. So the problem that Shobit was asking about was this guy. So, excuse me. So the question or at least the way you'd mentioned you did it and you weren't sure, was you said something like a double substitution. That's not the way I would describe it. So what I'm going to do is I'm going to do it, and I'm assuming what you're doing is what I'm doing. But I wouldn't call it a double substitution. That's misleading. So here's one way that you can solve this particular problem. So here, what I'm going to do is I'm going to set y to be the square root of s minus 1. So if I do that, this implies that dy ds is, remember, what's the derivative of the square root of s? That is 1 over 2 square roots of s. Do you have a question?
How about, I just had a question. Can we use only square root s if possible?
I mean, yeah, you can, but I mean, it works out to be the same pretty much. It's just, this is the way I choose. I'm pretty sure we could try it after this, but this is how I would first attack it. I believe you can, but let's do it this way first, and then we'll think about just using square root s. So if I do this, what happens? Well, remember, the way I sort of wanted you to think about this is you take your derivative and then use this idea of what we call differentials to write it in terms of dy's and ds's. So if I wanted, I could rewrite this as 1 over, so we got to get the s out of there. So what is ds? Well, ds is 1 over 2 root s times dy. That's equal to ds. So let's try this. Let's see what happens. So we'll switch colors because it's starting to wear on me. It's green. So the original integral, which is this, now becomes, so I have a 1 over a u, or excuse me, 1 over y, excuse me. And then what I end up having is my ds, I am going to replace it with this. Now, what you need to note is the square root of s, even though it shows up in there, I have another description for the square root of s. I can think of the square root of s as y plus 1. So the original integral can be written like this. This is one option. Now, if you clean this up and pull the 1/2 out, what you're left with is this. So we've written the integral that was unfamiliar to us in terms of a new integral. And it turns out this integral is likely unfamiliar to us. So before we say anything else about this problem, does anybody have a question? Going once, going twice. So again, make sure you understand how I got that y plus 1, where it came from. And by the way, what I did, I mean, I commented on what you said to be slightly misleading, and perhaps the way I said this, it's misleading as well. I'll explain what I mean in a second about that. Any questions?
Oh, okay, so I have one question, right?
Yes.
When it's, let's say when we have a variable over there, like y, for now we have y over there, y into y plus 1, right?
Yes.
So in a case like this, you have to find even the integral of that y, right? But if it's a number, you take it outside, like the constant, the way you did
Yeah, I could
for the
take a
half.
constant out. That's right. Yes.
But if it's a variable itself, you just leave it in and you find also the integral of that.
Yeah, that's exactly right. I mean, remember that integral means we're doing some sort of operation to a function or some sort of procedure to a function. So you can't pull a variable outside of the integral.
Okay.
Okay, so here's sort of the rub with this one. So if we look at this integral right here, we have sort of bad news. We can determine this integral let me clean that up. That's kind of, oh my God, my stomach is growling. So we can determine this integral, but we don't learn how till next semester. So the procedure or excuse me, the way that I attack this problem will work in general. However, this integral that is really 1 divided by a polynomial, how we integrate functions like this, we don't study that until next semester. And so in this particular instance, we're at a dead end unless we read ahead and learn how to do it. So what we do is we look for another method. So if I think about this problem, this is sort of the strategy we have, that we have to sort of agree that, maybe agree is a bad way of saying it, but you have to come up with some sort of mental process that you do in your head when you integrate. And so my process is try the obvious substitution. And for me, the obvious substitution in this problem was the whole denominator. Now, when I tried that obvious substitution, it got me to a dead end, at least, for the purposes of this exercise. I'm at a dead end, and the reason I'm at a dead end is because I don't know how to integrate 1 over y times y plus 1. Not yet, at least. So what this tells me, and this should be part of your integration strategy, when you have an integral and you need to determine what is the way your brain thinks about the obvious substitution, and then try it, and if it doesn't work, try something else. So let's try something else. Instead of that being y, let's try u equals the square root of s. So again, I try something, maybe it will work, maybe it doesn't, but I don't obviously see how it works. So now I try something else. This is sort of the strategy in which I employ, the O'Grady strategy, if you will. That's how I think about integrating these creatures. Okay, so let's do that. If we're going to choose u to be the square root of s, we know that means that du ds, the derivative, is 1 divided by 2 root s. And of course, we know that we can write this using our differentials. We can pretend it's a fraction, and we can write this. So we can say, okay, 1 over 2 root s times du is equal to ds. And just to be clear what I'm going to do, what is the square root of so what is the square root of s? Well, the square root of s is the square root of s, but it's also equal to u. So before we go any further, let's note that I don't want to say I lied, but I sort of did lie. And no one picked up on this in the last thing we did.
Which one?
Well, let's go back a second before we go any further. No one interjected. When I come over here, does this make any sense right here? Well, maybe I'll put it in red to be very clear. We talked about
No, it doesn't. It becomes
what,
2 square root s or dy equals to.
That's exactly right. That's exactly right. So again, this is why I tell you, you have to be very careful when you're doing these. This is incorrect. This is not, again, if you think about this line right here, if I want to write this using my differentials, that means I can put the ds over here. So really, if you think of this as in your algebra thing, I think that's the word you used, or we just doing algebra. Yeah, we're treating this as like a fraction, and the word you guys would most likely be familiar with, especially if you went to school in the United States, is this thing called cross multiplying that you learn in algebra class. So this is actually incorrect. This is wrong. What you do get, the correct reasoning, is that you get 2 root s dy equals ds. Now we're going to come back to this in a second, but let's just note, because of the importance that we can't even possibly know how to compute the integral correctly if we can't set it up correctly. So this is a very important learning moment. Down here, I thought I arrived at a new integral. But it turns out, even if I would have known how to integrate this, it wouldn't have mattered because it's not the correct integral. My mistake that I made, was done trying to figure out how my variable and my differentials change under this change of variable. So since this is wrong, that also means that this is wrong. These two things aren't equal. Anyhow, we'll come back to that in a second. That being said, let's do this problem correctly. So I gave you 2 opportunities, and I had to break the news to you. So now let's do this reasoning correctly. So the correct reasoning is that 2 times the square root of s times du is equal to ds. Now, another way of writing that is that 2 times u du is equal to ds. Now, why are these 2 things equivalent? Well, the square root of s is equal to u. So if I'm going to give you a moment to think about any questions you might have. I'm trying to illustrate a very common error that happens when you're first learning this, and that is that many of us will get mistakes before. It won't be at the integration stage, it'll be at this changing from u, or from changing from one variable to the next.
You can choose any other variable, right? Like for me, I chose because it's next to S, so I just decided to use T.
Oh, you mean letter-wise? I don't care what letter you choose. You can call it cat if you want. The letter is irrelevant. You pick your favorite letter. You just can't use the same letter in different contexts, because that would be misleading. But as long as you choose a different letter, that's fine. Does that make sense?
Yeah, it does.
Okay, so let's put this puzzle together now. We can piece it together. So let's remember what we started with. Our original integral was this. And under our change of variable, we replace, this becomes u minus 1. If we do u equals the square root of s. Now, what is our ds? Our ds is 2u du. Now, I'd like to write this, pull the 2 out front, if I can. And then this becomes u divided by u minus 1 du.
I just had a question.
Yes.
I've been curious. Do you use a mouse to write on the whiteboard or?
Now I'm using this little pen.
Oh, okay.
Yeah, so I got this thing. It's like a pad. I don't know. Hold on. Let me see if and it's a pain. I mean, I'm getting better at it, but you can see you write on this pad, and that's what's difficult because my camera's here, but I have another monitor over here, and so I'm writing and I'm reading to make sure it looks good on the monitor, so it looks like I'm never looking at you guys. I feel bad.
Oh,
Doing the best I can. No, yeah, this is interesting. Okay, does anybody have a question about this? Okay, now here's where you have to have some ingenuity. I think I mentioned on Friday when I gave you hints. I said you got to do a substitution and then you got to get a little creative. Because right now this integral is not obvious. But what I'm going to do is I'm going to make it obvious by putting a standard trick in there. So I'm going to get some creativity. I'm going to say, okay, let's upstairs, I'm going to add and subtract something. I'm just going to add 0 to this thing. And I'm going to show you why I'm going to do that in a second. So I'm going to write this as u. But what I'm going to do is I'm going to add 0. And so how I'm going to add 0 is I'm first going to subtract 1. And then I'm going to add 1. And so I'm going to get full circle to your the reason that this is not how I would do the problem. And it's because of this. You have to be a little too creative here. And I'll show you another way to do this in a second.
so wait, why did you say you have to minus 1 and add 1?
Well, because I'm adding 0. And if I want to put 1 in there, I got to take it away. Now here's where the creativity comes. I'm going to break this into 2 integrals now. This becomes u minus 1 over u minus 1 plus 1 over u minus 1. And why did I choose to write that in the red stuff? Because what does this integral? This is just 1. So you can see this is a challenging integral. I'm not even done yet. I've just reduced it to this. Let me erase that. This is not an obvious integral. It's quite challenging. We're not done yet. So let me reiterate. I wrote minus 1 plus 1 in red. I was being creative. If I look at this integral right here where I'm circling my pen around, I didn't know how to integrate that. I don't know how to integrate it. So the first thing I say is, okay, is there some algebra that I can do so that it becomes something I can integrate? And because I've had practice, because I've done this before, I know that this quote unquote adding 0, this trick works. It
So
allows me to split the fraction into two.
so you use -1 + 1 because we have a -1
Downstairs, that's right.
downstairs. So if it was another number, you write let's say if it was 3, so you'll use -3 + 3, right?
That's exactly right. Yep.
Okay.
Yep. And that works in lots of problems. You're absolutely right.
I mean, it's interesting to know about it because I never thought of that way.
Right. So this is it's I don't want to call it a trick because it's not a trick. It's a method that works. I mean, these ideas of manipulating an expression, they're not new to you. I mean, from the first time you learned how to add fractions with different denominators, that's what you were doing. You were multiplying things by 1. You know, you would multiply by 1, but you would never write it as 1. You might write like, you know, again, just, I know this is kind of going off topic, but it's worth noting that if you wanted to add like 2/3 plus 5, what would you do? You would say, okay, this is 2/3 plus 5 times 1. And then that's 2/3 plus 5 times 3/3. And then you'd say, okay, this is 2 plus 15/3. That's how you did adding fractions with different denominators. Now you usually, once you get good at it, you don't write these intermediate steps down. But this was the trick. You're multiplying 5 by 1, only you're not using 1, you're using 3/3. And that gives you the common denominator. So this, along the same kind of reasoning, what we're doing in this integration is we say we got a -1 downstairs. How can we manipulate it so that it's easier to integrate, or we can integrate it? And one sort of method of doing that is doing this subtract and add business. So hopefully you'll think about that and it'll make some sense to you. Okay, so now we can finish this problem because we know how to integrate both pieces. So now
when you go to the previous slide,
yeah,
can we just clear that up, like by u minus 1 and u minus 1 becomes 1?
you talking about this right here?
Yeah.
Yeah, that's
This
exactly right.
becomes 1.
It's exactly right. It's 1. That's how I got the 1 here. If I have something divided by itself and it's not 0, then anything divided by itself is 1.
Yeah.
Okay, so we have to do a little bit of reasoning, and this might be where you said the double substitution comes in. So to finish, we need one more substitution. So let's show you what I mean by that. We're left with this. So we can break this into two integrals. This is the integral of 1 du plus 2 times the integral of 1 over u minus 1 du. Now the integral of 1 is just the variable, so this becomes 2 times u. But we still have to handle this guy. And so when I say we have one more substitution, that's because this is the natural log of u minus 1. But the way you get that is I'm mentally doing a substitution. So it should be pointed out, and I highly encourage you think about this when you're reviewing this.
So I was just going to ask you about that, right?
Yeah.
Because I reached that point, right? But then can we use two different variables in one question?
Yeah, just introduce another letter. How about we use, I don't know, let's use, I already used y and u. Pick another letter.
T.
Pick x. let x be u minus 1. And then what's dx? Well, dx becomes just du. And you end up getting that integral. So you should work it out for yourself and make sure that you follow. And then we can finish this problem by plugging what the original variable back in, which was the square root of s. And so that is the final answer, if you will, the correct. Antiderivative, or the correct integral, if you will.
It's okay if we factor it, right? Like 2 into s square root of s plus square root of s minus 1. Because they have two.
You can't
2
factor.
is common in both of them.
Say that again.
So the 2 is common in both of them, right? We can do 2 into square root s
If you
plus
want to pull
square root s.
you could pull the 2 out, sure. Yep. So this is a good exercise because it shows lots of different things that can happen. Sometimes you need more than one substitution to finish a problem. And then also, sometimes we have to be creative with whether it's algebra or something else. And then another thing that's going to be interesting is we're now going to do this problem a different way. And we're going to see that we get the same answer. Before we do that, though, does anybody have a question about this? Comments, concerns? Okay, so let's do it. Let's do it another way now. So let's rework with, let's go back to the one substitution that I started with in the very beginning. And that substitution was I let u, did I use u? What letter did I use? I don't even remember.
You used y.
I use y, yeah. Let's go back and use y, and let's make it the whole denominator. And so if I do that, I get this creature. And of course, I can now, what is my square root of s? My square root of s is y plus 1. So I'll let you catch up with that. That's essentially what we did in the very beginning, only when I did my differentials, I did poor algebra, like you will often do. And so we thought we hit a dead end, but we actually were incorrect to begin with.
I have a question over there.
Please ask. Yeah, please. That's what we're here for. Don't ever ask if you can ask. Just ask. I wish you guys would just scream it out. It makes me feel like you're paying attention. What's up?
So instead of doing 2 into y plus 1, right? I mean, that's correct. But is it possible when you're doing double substitution, yeah? You just substitute the whole, like 2 square root s when you go down. Like when you walk
can leave it in that, but eventually you're going to have to get rid of the s. So I'm just getting rid of it now. Yeah. And I think your question's a good question because I'm getting rid of it now because I know what's going to happen. So your point is very well taken. If you were doing this on your own for the first time, you probably wouldn't have that last line there because you probably wouldn't know that you need it. So, maybe that's sort of like the bias of knowing what I'm doing versus you guys who don't know what you're doing yet. So let me say that again. I think what you're pointing out is this last line I wrote, that wouldn't be obvious to you to write that right away.
Yeah.
right? And that's fine. I'm writing it sort of because I already know what's going to happen because I've done this problem 4,000 times in my life and problems just like it. So yeah, I mean, that's one of the unfortunate things about like reading problems and solutions and books and watching videos is oftentimes the solution is written out, and the person writing the solution, and I'm guilty of this a lot, is we don't remember what it's like all the time to be in your shoes where you don't see the obvious thing. So yeah, I think what I would have probably done when I was in your position is I would have left this last line out. And then I would have realized later that I need to do it. Does that make sense?
Yeah, it does.
Yeah. So, and let me illustrate what I mean by actually doing it. So we start with the problem. What was our problem? It was this. This becomes, well, it becomes 1 over y. Now, if I wouldn't have written that, I would have written this. And then you might think you're stuck, but you're not, because you can replace this with this. And now this is the same exact problem from the previous page, only we're using different letters. Because now this becomes y plus 1 over y. And you see here, we don't need that trick because it already simplifies for us. 1 over 1, or y over y is 1, and then you get this. And it's the same integral. Literally, this is the same integral using a different letter than we had on the previous page. As we would expect, because we started with the same integral. So we basically went to grandma's house 2 different ways. And it's all personal preference which one of these solutions and you'd have to decide which method you like.
Will it be correct? This is just another way of saying it. Will it be correct if we just substitute 2 square root s with another letter? Like with another variable?
No, that would not be. No. That would be, and it does it even, I don't even think you'd be able to get it work out. Why would you want a new letter? Then you'd have 3 letters floating around.
I mean, that's right, but I was just checking out, like, when I was thinking about it, like, I wanted to really know what it was going to happen, like, what's going to happen. So I tried to watch a YouTube video, and that's what they did. That's what
So
I was
they
asking.
replaced S with another letter?
No, like 2 square root s, right? So
Yeah.
the way we did y equals to square root s minus 1, they
Okay.
did the same thing for, let's say they used another variable over there, x equals to 2 square root s. And then it becomes 1 over y multiplied by x.
Okay, yeah, they're just using a different substitution. You could do that if you wanted. They're using a constant in there. Yeah, I mean, one of the things you'll find, and I mentioned this to you not on Friday but on Thursday. Everybody has their own way that they prefer to choose substitutions. This substitution rule, people like to do it in different ways, the way that they're imagining the formula to work. So it's personal preference. I guess what you're saying is what someone probably did is they want to cancel that 2 out. So they probably chose y equal to be the square 2 times root s in the beginning. And then you just have 1 less constant. It's just a different way of doing it. As long as you follow the reasoning behind this change of variables theorem, then it's okay doesn't matter how you choose your substitution as long as you do it logically sound. Does that make sense?
Yeah, it does.
Any other questions about this problem?
So which from this first one we did and this second one we did, like with the square root s and square root s minus 1, which one will you suggest?
I would prefer this last method, but that's, it doesn't matter. there's not a right and wrong answer to this. I mean, if there's multiple methods that work, then it comes down to what method do you prefer? Again, it just comes to personal preference. That's it. Any other questions about this problem? And that's it. All right. So, yeah, someone said.
How about if we had x squared downstairs instead of square root s?
Well, if it was x squared minus
1, yeah.
Okay, that requires. Well, so I'm going to sneeze first, I think, and then I'll answer your question. Oh, something went in my nose. So I think your question was something like this. This creature?
Yeah.
Yeah, okay, so this requires a technique called partial fractions, which we learn about next semester. But here's the idea. The idea is to note that the denominator can be factored. It's a difference of squares. And then you have to break it into two fractions. So you probably did this in an algebra class. If you Google it, you might remember some different examples. So basically, if you look at this integral, you have the idea is you have a one fraction. And what you'd like to do is you'd like to decompose it into two fractions, because the original fraction you don't know how to integrate. But what you can do is you can notice that this thing can be written like this. It can be written in this form. 1/2 over this minus 1/2 over this. So I'm just writing it down because I know the answer. You don't right now, but the observation is to write one fraction is more than one fraction, because the ones on the right you do know how to integrate.
So wait, if you do minus, right, wouldn't it become 0 on top?
No, because they don't have a common denominator. Multiply it. No, work right to left instead of left to right. Find a common denominator and subtract those two fractions, and you'll get exactly what you started with on the left. So one of the problem with partial fractions is you have to work the opposite way. You're given one fraction and you want to decompose it into multiple fractions. And we'll teach you that strategy in the next semester for those of you who take in Calc 2.
So what I was actually thinking of, yeah, like the way I will do this, if you didn't tell us that way, I would have done 1 over x minus 1, multiply 1 over x plus 1, then separate those two and find the separate integrals.
Yeah, but you can't separate a product. That's creating your own rules. You can't separate the product. You can only separate the sum or the difference. So I think this is what you're trying to say. You're trying to create something that's illegal. You have to understand that, note 1 over x minus 1 times 1 over x plus 1. This integral is not equal to the product of the integrals. That is not true. That is some cheating things. I mean, think about it. Why would you expect this to be true? How do you differentiate a product? You have the product rule, right?
Yeah.
So why do we think if it's difficult to not difficult, but if the process of differentiating the product requires this role that doesn't seem intuitive, why would you expect integration of a product to be some simple thing? It's not. You can't separate the product. You can only separate the sum and difference. Is that clear?
Yeah.
So, and again, but there's no reason someone in your shoes is a calculus student for the first time. Of course, you're going to probably incorrectly think that things work that way. They just don't. But that's a good question. And by the way, sometimes it's good. You know, I've said this to you guys many times. There's nothing wrong with trying things illegally and even if you don't, well, the idea is you don't know it's illegal yet. Making errors is one of the ways we learn. You know, it's just how we do it. We learn by trial and error. You learn to walk by falling. Right? None of you were babies and then one day you're sick and tired of watching everyone walk and just jumped up and walked. That's not how it worked. You know, you kept watching people around you walk and you kept trying and you kept falling on your ass. And eventually, after you fell a gazillion times, you learned how to walk. And then you got cocky because once you learned how to walk, you're like, well, maybe I'll go fast. And then you fell on your ass again a bunch, right? You know, learning is very much just like that. It's a process. So, you know, I can't emphasize enough. You can't look at like a homework in calculus and say, okay, I'll just do them, because that ain't how it works. The way you do this, the way you learn, is that you have to understand you're going to get them wrong at first. And then eventually your skills, you know, become more refined and you stop making as many mistakes. That's how you learn. This doesn't happen overnight. So don't get discouraged when you get it wrong. That's just part of it. All right. Any other questions about this problem or any other problems on here?
So then how will you find the integral of what you just...
How would I do which one?
The one you just decomposed, right? Half over, yeah.
Oh, this thing? Well, now these are just both logs. You could do both both of these would just be simple U substitution natural logs. So you know, if you wanted me to finish it, what you would say is the following. You would say, to be specific, you would say this. You would say that this is 1/2 the integral of 1 over x minus 1 dx minus 1/2 the integral of 1 over x plus 1 dx. So I'm just writing. So if I go to the previous page, I'm putting the 1/2 in front just because it's cleaner looking. And then I'm just going to take the difference of both, which I can, because I can separate the difference. I can't separate the product. So what I mean by separate is I wrote the difference of these two functions, their integral of the difference, as the difference of the integrals. And then if you do the correct U substitution, you get 1/2 log of x minus 1. And then here you get minus 1/2 the log of x plus 1. And then it's plus some constant c. So it's worth pointing out that I'm actually doing a mental substitution here. What do I mean by that? So if you want to follow along, this step I used say u equals x minus 1, du equals dx, and here I'm using a u equals x plus 1, du equals dx. So to help illustrate further.
So wait, you can use another letter for x plus 1, right? Because if you put both of them here, at some point you'll be confused.
Oh, right. Right. You know, ideally you might want to use a different letter, but it doesn't matter. I mean, look, it doesn't matter if you use the same letter twice as long as you're not using it in two different contexts. I'm not using it in two different contexts here because I have two separate integrals. But
Yeah.
you're right. When you're learning this, it might be better to call one U and the other Y or something like that. But it should be pointed out that what I did there is a substitution, and let me explain why. So suppose I wanted to integrate something similar to that. Suppose I had 1 over, how about 4x plus 5. Many of you would incorrectly do this. This is wrong. The correct way is to do a substitution. So what do I mean by that? The correct way, whether you do this in your head, some of you will get good at doing this in your head. Others have to write it down. So the correct way is to do a substitution. So let's use a different color here. What is the correct substitution? Well, the correct substitution here would be, say, y equals 4x plus 5. And then dy is equal to 4 dx. And so if you do that properly, this actually becomes 1/4 the integral of 1 over y dy, which equals 1/4 the log of y plus c. And so the correct answer is 1/4 log of 4x plus 5. So this is a very important point that I would hope you guys consider. You don't want to get in the habit of thinking that there's a pattern there that's not there.
Why did you put dy equals to 4 dx?
Why did I put what? dy equals 4 dx?
Yeah,
Now what's the derivative of 4x plus 5?
it's 4.
Yeah, so if I write it in differentials, it's 4y equals 4 dx.
So I had a question about it again now. So when you said that dy equals to 4 dx, right? So when you replace that dy over there, right, in the equation, it becomes the integral sign 1 over y multiplied by 4 dx, right?
No. I'm not replacing y. I'm replacing x with y. So it's 1/4.
I get that, right? But when you just replace it that way, the way you have okay, wait, it's not possible because you have used y already, right?
That's correct, yes.
Okay.
Excuse me.
Yeah.
Yeah, this will be uploaded later on today, right? Because I gotta head out.
Yeah, absolutely.
All right.
Yep. So this example is extremely important. I hope you guys ponder it and consider it.
I just want to make it clear, right? So the dy or dx you write at the end when you're integrating, it depends on the variable that you are going to integrate at the end. So in this case, you're gonna, if it was x, you'll use dx, but it's y, so you're using dy at the end.
That's correct. Yeah.
So if it's different, you know that there's a problem.
That's correct, unless you can remedy that problem. Now, we in those examples before, it looked like there was a problem, but there wasn't. We were able to get rid of it just by being creative. But yeah, that doesn't, there's often, a substitution doesn't always work. So let me explain what I mean by that. So I think I did this last week, but it's worth doing again. So let's take a similar problem. Let's take something like,
You did of 1 over x minus 36 x squared.
wait, say that again?
1 over x minus 36 x squared.
Yeah, this one would use partial fractions. So this one, you can't do this one with a substitution. So this guy can't be done.
Wait, I sorry, it's 1 minus 36 x squared. I'm sorry.
Right. Okay, well, okay, but let's just do this one because the one you said can be done. It just requires more tricks. This guy can't be done by substitution. You cannot do this by setting, say, u equal to x minus 36x squared. It can't be done. Try it. When you plug it in, you're going to have you're going to have two variables floating around and you can't get rid of one. It can't be done that way. Now, you said this guy, you said 1 minus 36x squared, this?
Yeah, that's the one you used last time.
Yeah, this one requires partial fractions. And so that's a Calc 2 topic. That one you have to factor and do what we just did before. Substitution only works on certain integrals. It doesn't work for all of them.
So you also said that the second thing what we wrote can be written as 6x squared, right?
Wait, say that again?
So over there, 1 over 1 minus 36x squared, right?
Yes.
So this 6x squared can be written the same as 6x squared, right?
Yeah, but the substitution won't work with this one.
Yeah, I get that, but you can write it that way, right? You don't need to.
Yeah, you can write it as 6x quantity squared for sure. But even so, you can't do, it's not gonna, that won't help you with this particular integral. Now, if I modified it, if I had this integral, if I had this guy can be done. Well, here you let say y equal 1 minus 36x squared. That's what's going to work here. And then if you do that, you get dy is equal to negative 72x dx. And now if I plug that stuff in, if I plug everything in, I get x over 1 minus, or excuse me, x over y. So here's one way to do the substitution. You get x over y, and then what's dx? Well, x dx becomes, you have your negative 1 over 72, and then you have times 1 over x dy. And so here, the x's cancel out, and all that remains is this. So the x's are not an issue here because they cancel out, if you will, cancel out. And so this becomes negative 1 over 72 log y, which is negative 1 over 72 log 1 minus 36x squared. So what you're trying to recognize is you're trying to look for patterns that aren't there. And again, that's just what happens when you're learning. And it's also what happens because many of us spend so much time in school math just doing the same freaking things over and over again that we think that that's what math is, and that's just not. So these are all good examples because they look the same except for one small detail, yet they're all computed differently. And what you should study is you should study why one solution is done a certain way and why the other ones can't be done that way. Okay, does anybody have a question?
So whenever you find, let's say, D and a certain letter over D and a certain letter, it always means it's differentiation, right? In calculus.
Oh, when you see like I mean, in the right context, yes. Dy means the differential, dx means differential. And then if you write dy over dx, that means a derivative.
And what if we use, let's say, maybe ds over dt? Will that be also differentiation? Or?
Yes, absolutely. That's different.
Okay.
Yeah. I mean, anytime you see, I mean, look, context is everything. It's possible the letter D can show up and not mean derivative, but you know, look, if you're using context clues, almost surely every time you see the letter D in this class, it's going to often be for derivative.
And then another question I had was, it's not about the course itself, but I learned about this alpha and beta thing. So which course does it fall under, alpha and beta?
I don't know what you mean by alpha and beta. You mean
So
the letter alpha and beta?
Yeah,
I
like
mean, alpha and
so
beta are Greek letters. They're used in all kinds of contexts. I don't know.
because there's a way I learned was like, let's say if it's alpha plus beta, right? Alpha plus beta squared, both of them when you bracket and you do squared. So when you, I don't know, it's just different. So I just wanted to ask which course
I
does
mean,
it
you
follow?
just might be. Look, it just depends on what letters people like to use. I mean, okay, I don't know if this is exactly what you're asking, but I think it's what you're asking. I mean, if I wanted to state an algebraic fact, I could write this fact: a plus b squared is a squared plus 2ab plus b squared. This is an algebraic fact. If a and b are real numbers, that's a true fact, or that's
Yeah.
a fact on it. Okay, well, there's nothing special about a and b. If I wanted, I could use x and y. If I use x and y, the formula is the same. It's just what symbols am I using? And for that matter, if I like Greek letters more than I like, if I like Greek letters more than I like these English letters, I could use alpha and beta. So some people like Greek letters, and this would be alpha squared plus 2 alpha beta plus beta squared. Suppose you don't like the alphabet letters. Suppose you like symbols. Well, say you had star plus square. Well,
Okay, it's actually funny for me because when I was doing that in high school, I
yeah.
thought that these are all different topic about alpha and beta, but now
No,
I
no, no.
just
I
realized it's
mean,
the
this
same.
is just what symbols do we like? That's all this is.
Yeah, I
Well,
just feel like laughing for my
no, and
not
that's okay. It's often, as I said, part of the downside to the way math is taught, uh, particularly when we're younger, is it's all about like learn something and then do it a gazillion times. Uh, and I don't know, but what that does is that means if we have one teacher that does it a certain way and then we go see it from another teacher, we might think that two things that are the same are completely different. So yeah, I mean, the letter is immaterial. We just all, it's just convention, and some people like different letters. I mean, hey, there's nothing special about this. Maybe I'll use N and M. And then in this case, it's N squared plus 2NM plus M squared. These all represent the same mathematical fact. It's just 5 different ways of writing it. Does that make sense?
yeah, it does.
And again, one of the things, it's convention, but it doesn't mean it's the rule. But typically we use letters like A and B to represent some constants they're numbers, but they're just generic numbers. They're arbitrary. We typically use letters like X and Y to represent variables. Those are things that vary. Now, some people like to use Greek letters. A lot of times we use Greek letters like alpha and beta and theta when we're talking about angles. That's a very common convention. But there's no rules out there that says if you're doing algebra, you must use X for the unknown. I mean, as you've seen in this class, sometimes we use T because T is a good unknown because a lot of things in the physical world are dependent on time. So we use T to represent that time is the variable. So there's no set rule. It's just sort of conventions. All right. Any other questions about this?
No.
All right. Does anybody else have any calculus questions before we begin? Or begin before we end. Jesus. This is it. This is the final hurrah.
So wait, I was just thinking about when I'll be taking calculus 3, right? So it won't be offered in spring. Next spring, calculus 3 won't be offered.
Well, it depends. Are you taking calculus 2 in the summer or the fall?
The fall.
Okay, if you take it in the fall, then hopefully calculus 3 will be offered in the spring. We try to offer it every semester.
Yeah. So I was just wondering. I was just wondering if you'll be available for that course, because since you said that you don't teach all calculus 3 classes.
It just depends. I've taught it the last 2 semesters. There's no guarantee I'll teach it that semester. It depends on what classes we have to offer. It's always up in the air. yeah, so I can't. It's hard for me to say a year in advance what classes I'll teach. Usually, where we go one semester, we usually don't make the spring schedule until halfway through the fall.
Okay.
But that reminds me, if any of you are considering taking summer classes, they're all online. You know, so no matter where you live, if you want to take them, you can. And for those of you who are in, you know, math heavy disciplines, particularly engineering, you know, the sooner you get your math out of the way, the better, because you got to take a lot of math. So I know it's not always possible for everybody to take summer classes for whatever reason, you know, logistics, finances, whatever. But if you can, I would encourage you to take Calc 2 over the summer if you have to take more math. Because I know a few of you are in the engineering track and you're going to be taking lots of math. And so you can't take those upper level courses until you get Calculus 1 and 2 out of the way. Plus, I would also, you know, again, everybody's different with their finances and their lives. But it's, you know, taking summer classes is a good way to stay ahead, particularly if you have a demanding major. And engineering is a super demanding major as far as how many credits you need.
So I just wanted to ask you about that too. Since my major is math major, so I was just thinking, will it be okay for me to take it?
Say that again. You went in and out. I didn't hear you first. Your major.
So my major is math. So if I take it in fall, calculus 2, it's fine, right?
I mean, yeah, it's fine. I mean, you take it when you can take it, but I'm saying ideally you'd like to take it in the summer if you can. If not, you just take it in the fall. That's fine. Yeah. It's not like you're be in trouble. No one's gonna yell at you for that.
And then there's this thing I saw in the course when I was saying my degree audit or what it was. So what's the difference between the probability and statistics that starts with 1040
Yeah,
and
that's a
3040?
non-science class. So that's a good question. If you are, and some of you should have to listen, there's two versions of prob and stats. There's Math 1040, which is mostly geared towards non-science majors like psychology and you know, certain business majors. That is a non-calculus based prob course. If you're in engineering, you don't need that course. You need what I call the real prob and stats, which is calculus based. That's like Math 30 something. You cannot take that class until you've had calculus 3. What's that?
So the one you're taking of it's 3040, right?
That's correct. Yes, that's
Okay.
the one that and the engineering students must take. Yes, or the math students, or you know, the other class, the 1040, is not meant for science majors or math majors or engineers.
Okay.
All right. Okay. Any other questions? These are good questions. See, we're learning today. All right. Well, listen, if you guys don't have questions, I will end this. Please blow up my email if you have issues about anything. And I'm not ignoring you. I'm trying to answer emails as I can. I will put these notes up right now on Canvas. I will upload the video to the YouTube machine. And please be on the lookout. Yeah, what's up?
So you remember we collected our assignments this first half of the semester?
Yes.
So I was just asking, do you think when we come back in the fall, do you think I will get them back? Because I was making a collection of my assignments. That's why.
Yeah, you can. I just can't get in the office right now, or I'd get them for you.
Yeah. Like in the fall, it's fine, right?
Yeah, it should be. Yeah.
Okay.
Unless they banish us from campus forever. No, yeah, we should be fine. Once we're allowed back on campus, I'll get you anything that's left there. I have some stuff here. I went to the office the one day right before they the governor shut everything down, and I didn't think to grab everything. I just grabbed certain things. So in retrospect, I messed that up, but there's nothing I can do about it now. But yeah, anything you want in the future, just holler and I'll get it for you. All right.
Yep.
All right. Listen, well, you guys, good luck on any finals you have, anything like that. If you have any questions that I can help you with, or if you want to do a Zoom review or anything, all you got to do is blow up my email. Send it. And by the way, I will say this real quick. If you send an email, that has problems in it or any like something you're trying to submit, don't resend that again and again and again, because I only need one copy of that. That gets confusing. But if you have a question, please keep sending that email over and over again. All right. Best of luck, guys. Be safe, and thank you.
Yep.
I
So
hope
no
to
class
hear
on
from
Thursday, right?
no class on Thursday or Friday, but I am willing to do Zoom review sessions if you want. So just have to send me an email, and we'll try to schedule something.
Okay.
All right, guys. Good luck. Thank you very much. Be safe.
You too.
Yep. Bye now.